Okay, this is exam 3 for Physics 201, Fall 2016. The first problem we have here, it takes 100 meters to stop a car initially moving at 25 meters per second. Under the same conditions, how far would it take a car traveling 50 meters per second to stop? So here we're dealing with the kinetic energy that we have is being taken away by some force that is acting over some distance. So this is work energy theorem. My kinetic energy is 1/2 mv squared, and then the force and the distance. Now, if I double if I traveling 25 meters per second, it takes me 100 meters. What happens then if I double my speed, then I quadruple my distance. So whereas it did take 100 meters, now it's going to take 400 meters. Consider this figure. A cart starts at point A with a speed of 4 meters per second. Which of the following describes the cart's energy at point C? At point C, it's going to have potential energy because it's some height above the ground. It's also going to have kinetic energy. It actually had kinetic energy over here, and now it's going to be at a lower height at point C. So some of the potential that it had over here will now be converted into kinetic energy at point C. And besides, it's going to have this kinetic energy plus some. So it actually have more kinetic energy than it had at point A. That's really more than you need to know. But at point C, these should all say point C, and I will fix that. At point C, the potential energy is greater than 0, and the kinetic energy is greater than 0. Which of these statements is true? Conservative forces require contact between two objects? Not true. Actually, they don't require contact, or they should not have contact. Field forces conserve energy? That's true. Friction is a conservative force? Not a true statement. Conservative forces are path independent, not dependent. So looks like C is the right answer. Father pushes his child on a swing. He pushes with a force of 30 newtons for a distance of 2 meters. How much work did the father do? Well, work is force times distance. 30 times 2 is 60 joules. Rank these situations by their work done by the force from least to greatest. Well, the one that does the least work is this one. It does 0 work because notice the force is perpendicular to the displacement, so it does 0 work. Then this does the next biggest work, and then this does the most work of all. So from least to greatest is 3, 2, 1. E is the right answer. Which of these is the basic SI unit for work? Well, force times distance. That is a kilogram meter per second squared times the distance, which is another meter, so it's kilogram meter squared per second squared. Which of these does negative work? This one does negative work because the force and the displacement are opposite. This one also does negative work, so B and D. When the momentum of an object increases with respect to time, what is true of the net force acting on it? Okay, so F is equal to delta P over delta T. And what this is saying is that the momentum of the object increases with respect to time. So that means that this value is bigger than 0. It is getting bigger. The change in P with respect to T is getting bigger. So that means that F is also bigger than 0. So we can get rid of A and C, because we know force is not 0, is non-zero because the net force is equal to the product of the momentum and the time interval. Well, that's not true. It's the quotient, not the product, because the net force is equal to the rate of change of the momentum. And that's what this is. This is the rate of change of momentum. Anytime I say a rate of change, I'm talking about how that thing changes with time. Here we have a uranium nucleus undergoes fission. It splits into 2 fragments. Which of these statements is true? Okay, first, it has no momentum. Pi equals 0. And then it breaks into 2 pieces. So this momentum will equal to this momentum, except one will be opposite the other, because they add up to equal to 0. So let's look at the options. Oh, the lighter object will move faster because it's lighter. P equals mv. If m goes down, v goes up. If p is constant, the heavier one will move slower. The lighter and heavier fragments have the same speed. The heavier ones travel slower. The lighter fragment has a greater speed. That's true. Heavier fragment has more momentum. They both have the same magnitude of the momentum. And the lighter fragment has more momentum. It travels faster, but it doesn't have more momentum. Which of these statements is true? Both energy and momentum are vector quantities? No, energy is scalar. momentum is a vector. So D is the right answer. You push an object along a rough surface. Which of these best describes the work done by the frictional force? The frictional force opposes the direction of motion, so the work done is negative. And who's my favorite student? John Thibodeau. Hey, he's pretty awesome, and so is Mary. And Grant, he's pretty good too. But D is the right answer for number 12. Obviously, that was a gimme. Okay, let's look at this. This is our two-body 2D problem. All right, so first we want to start drawing our coordinate systems here and here. Want to write all of our forces here. Was that a 10 kilogram object? Yes, it was. We will draw our forces on both. Here I have the normal force, Fn. I have the weight, Fw. I'll call this Fw1, and I'll call this Fn1. Here I have the frictional force, Fk, and then here I have the tension. Now that tension is the same as this tension, so I'll just label them as Ft. And then this is the normal force, Fn2, Fw2, and I think that's it. Okay, so let's deal with this first one over here. This one over here. Now, first off, I can say that the sum of the forces in the y direction is Fn1 minus Fw1, and that's equal to 0 because it's not moving in the y direction. So Fn1 is equal to Fw1, which is equal to m times g, which is 100 newtons. So that is my normal force, Fn1. Now, I can also say the sum of the forces in the x direction is Ft minus, minus Fk is equal to m1 times the acceleration. I don't need to put a subscript on the acceleration because both blocks are going to accelerate at the same rate. So I can just leave that as m1 times a, but I do need a subscript on the m because I'm dealing with my first mass. Now, since I know my normal force, I can figure out what Fk is. Fk is equal to mu times my normal force. This is Fn1. Mu is 0.1, it's right here, times my normal force, which is 100 newtons. So that's equal to 10 newtons. So I can rewrite this equation as Ft minus 10 equals, what was m1? Equals 10 times a. So that's my first equation. Notice there are two unknowns in it, and I don't know what those unknowns are. Now on my second equation, let's look at these over here. I have Fn2. I'm going to go ahead and resolve these force weight vectors into their x and y axes, noting that that angle is 60 degrees, so that's Fw2 cosine of 60, Fw2 sine of 60, and I have Ft. There's no friction on this, so I don't need to know my normal force. I'm really only dealing with my my x-axis. So I'm just going to write my sum of the forces in the x direction is going to be Fw2 cosine 60 minus Ft equals to m2 times a. Now again, m2 is important that I keep the subscript, but the a is not because it's going to have the same acceleration as block number 1. So the mass of this is 200. 200 cosine of 60 is a half, or 0.5, minus Ft equals to 20a. So that's 100 minus Ft equals 20a. Now we can solve these by substitution. I say let's solve this one for Ft equals 10 plus 10a. Now I'm going to take this and plug it in up here. So I get 100 minus 10 minus 10a equals 20a. That's 90 equals 30a. A equals 3 meters per second squared. And that's as we expected, that it should be going down the inclined plane, which is in the positive x direction. And then I can take this, that's part of my answer, and I can plug it in here, and I find that Ft equals 40 newtons. Now you could also solve this by Gaussian elimination and get extra credit, 5 points. So if you did so, good job to you. Let me just go through it. It actually works out pretty easily. But the first thing I want to do is rewrite these. I'm going to have Ft minus 10A equals 10. And then I have my other equation, which is right here. Ft plus 20A equals 100. I just write them in this way. Then I can write my matrix. I have 1, -1, 10, 1, 20, 100. Yours might have looked a little bit different than this, but you're going to get the same result. Like if you write your equations a little bit differently and put your variables in different positions, it can look a little bit different. The first thing I'll do, I want to make this 1 into a 0. So I have 1, -1, 10. I keep that one the same. And here I say I replace this row with this row minus this row. So I get 1 minus the first row, that's 0. 20 minus the first row, that's 21. Am I doing this right? Yeah, this should be 10, I'm sorry. So 20 minus -10, that's going to be 30, equals 100 minus 10, which is 90. So I've replaced the second row with the second row minus the first row. Now let's go and divide this by 3. So I get 1, -1, 10, by 30 rather, 0, 1, 3. Look, I already got A is equal to 3 meters per second squared. Now I need to get rid of this one. I'm just going to add the second row to the first row and replace the first row with that. So I have 1 plus 0 is 1. 1 plus -1 is 0. Oh, I'm sorry, this should be 0, 1. Give me just a moment here. I have a mistake. Let me find it. Okay, I'm very sorry about that. I made another mistake. I just didn't carry this 10 over, so make sure you get that 0 in there. And then this is 0, 30, 90, and then I get 0, 1, 3, but this should be 0, 10, or 1 minus 10, 10. And then I add 10 times this row, the second row, to the first row. So I get 1 plus 10 times 0 is 1. -10 plus 1 times 10 is 0, and then 10 plus 3 times 10 is 40, and then I get 0, 1, 3. So if you worked it in that way, that's a plus 5 for your effort. All right, consider these two particles have an inelastic collision. That means that momentum is conserved, but not energy. What is the final velocity of the second particle? Okay, so our initial momentum is m1v1i plus m2v2i. That's going to be 1 kilogram times 4i plus 1j plus 2 kilograms times -3i plus 1j. That's going to equal our final momentum, which is going to be m1, which is 1 kilogram, times -3i minus 2j, plus m2 times v2f. And I just solve for v2f, but keeping my i's and my j's all together. So I get 4i plus 1j, distributing these masses, minus 6i plus 2j equals to -3i minus 2j plus m2 was 2 v2f. Combine those I and j terms. Here I get a 4i and -2i plus 3 is positive 1i. I brought that plus -3 over, it becomes plus 3. And then I get 3j plus 2j, that's 5j. then divide the whole thing by 2 equals V2F. And so V2F equals 0.5I plus 2.5J. That's in meters per second. Cart begins at point A with a speed 4 meters per second. What is the speed of cart at point B? Well, here it has kinetic and potential energy. Down here, it only has kinetic energy. So for part A, I say 1/2 mv squared plus mgh equals 1/2 mv squared. We'll call this VA and this VB. The m's cancel, fortunately. 1/2 of VA squared, that's 1/2 of 16, 4 squared, plus 10, that's the acceleration due to gravity, times 10 meters, the height, equals 1/2 VB squared. It's 8 plus 100, 200 square root of 216 is VB, whatever that is. Now what is the speed of the cart at point C? So for B at point C, it's very similar. I have 1/2 mv squared plus mgh equals 1/2 mv squared plus mgh. Because at part C, I have both kinetic and potential. So my m's cancel. 1/2 of 4 squared, that's 16, plus 10 times 10 meters, that's this height, equals 1/2 of v squared plus 10, that's g, times h, which is 8. And that's 108 minus 80 times 2 square root of that equals v, and that is equal to calculator. 108 minus 80 is 28 times 2 square root of that. V is 7.5 meters per second. And then finally in part C, looks like this. What is the height at this point? So I say the total energy at point A, 1/2 mv squared plus mgh equals to mgh, which is, at this point it only has potential energy. M's cancel again. 1/2 of v squared, that was 4 meters per second, plus 10 meters per second squared times 10 meters equals 10 meters per second squared times h. So 108 divided by 10 equals 11 meters. So that's h. It goes up to 11 meters right here. All right. Force pushes on an object through a displacement. The object has a mass of 2 kilograms. What work has been done? All right, well, F dot D is our work. Told you you'd have a dot product. Here we go. I have 3I plus 4K. Dotted with 10I plus 3J minus 2K. Remember, you just multiply the like terms. I dot I is 1, so that's 30 times 1, plus K dot K is 1, so that's negative 8 times 1. So that's equal to 22 joules. This thing has 22 joules of energy. The speed of the object, B, the speed of the object, if it does that much work, it goes into kinetic energy. 22 joules equals 1/2 mv squared. So solving that for V, 44 divided by the mass, which is 2 kilograms. Take the square root of that. That's square root of 22, which is 4.7. And then C, a force acts given by this function, 3x squared, to cause the object to stop, how far does the object travel before stopping? So it has 22 joules of energy. And then it's taken away by some force that acts over a distance as it travels from 0 to x. And so we want to figure out what that x is. So we say 22 is the integral of the force, which was 3x squared. Notice that it's 3x squared I. Really what we're doing here is we're doing a dot product of two vectors and then integrating it. But x is in the I direction, our force is in the I direction. I've made it so that you don't really need to worry about the dot product, but really that's what you're doing, is that you're taking a dot product before you do the integral, or as you're doing the integral even. You'll get to this in calculus 3, you chem majors at least, and your engineering majors. So the integral of 3x squared dx, 22 is 3x cubed over 3. Remember, the integral of ax to the n dx is ax to the n plus 1 over n plus 1. Make sure you know your integrals of your polynomials. 3's cancel. 22 is x cubed. That's going to be x is 22 to the 1/3 power, or the cubed root of 22, if you have that on your calculator. Ooh, do I? I do. I get 2.8 meters. 2.8 times 2.8 times 2.8 is 22. All right. Crane drops a steel ball into a steel plate, Just before impact, the ball is traveling at 3.6 meters per second. Negative 3.6 because it's going down. And then it bounces off the steel plate, and now it's going 6.4 meters per second. It takes a time equal to 0.03 seconds. And I want to know, what is the magnitude of the force? Well, force is delta P over delta T. That's the mass times delta V over delta T. This is Newton's second law, right? This is our acceleration, delta V over delta T. There's our mass. Our mass was 0.2 kilograms. Delta V is 6.4, that's my final, minus my initial, which is negative 3.6 meters per second, divided by our time, which is 0.03 seconds. And so that is, well, let's see, 0.2 times 10, so it's 2 divided by 0.03. 67 newtons. Get my sig figs right there. Yeah, 2 sig figs, 67 newtons. Oh, and that's the end.